Hello everyone. As our term assignment for section examination, we have been offered to present the topic Parkinson Gear Tester. This is me, Dev Sethi from Mechanical Engineering Department, roll number 30. And here's my friend Dishang Mehta from Mechanical Engineering Department as well, roll number 64. The tester is basically used to check any kind of error in the gear. Now let's discuss some points about gear. A gear is a machine part having cut teeth which mesh with another part to transmit the torque. Basically, basic use of the gear is to change the speed, torque in direction of a power source. There can be many types of gears like external gear, internal gear, spur gear, helical gear, double helical gear, skew gears, bevel gears, hypoid gears, and many others. So with these many types of gears, there can be various types of errors associated with them. So when two gears are closed, meshed, and rotated, any error in the form, pitch, or concentricity of pitch line will cause a variation in center distance. Parkinson gear tester is a measuring instrument for gear profile measurement. It gives reading with the help of a standard gear and a dial gauge. Moving next to the working principle of the Parkinson gear tester. The basic principle on which uh, the Parkinson gear tester works is that there will be some deflection observed when a correct gear is being matched with an errored gear. Here, as shown in the figure, we can see that there is one gear which is a master gear and another is testing gear. The master gear is fixed firmly, but its position can be adjusted, and testing gear is on a movable carriage which is connected to the master gear with the help of a spring, so that during the rotation of the gears, the teeth of both the gear are in contact and meshed. The dial gauge is kept attached to the carriage. If there is any type of error, then the carriage will move and the dial gauge will show the readings in it. As you can see in the figure, that a recorder can also be connected to it, so the quality of the gear can be known easily. As we said about the quality of gear, so let's discuss about it a bit. The quality of gear depends upon many aspects and can be majorly divided into three types. First, fully satisfactory, which means there is no any chance of any defect or error in the gear we are testing. Second comes moderate, which means there are some defects in the testing gear, but they can be resolved easily. Third is unsatisfactory, which reduces that there are a lot of defects or errors which can't be easily solved. Let's now move on to some of the special features of Parkinson gear tester so that we can know how it is different from the others. It is having the precisely measuring capacity and reproducibility of Parkinson gear tester machine due to stylus and pen and spring arrangement is highly sensitive. So however, a small variation in the flank of the gear tooth will deflect the stylus along with the pen. We get the consistent force on the job. Previously, the operations which this machine does were done individually in different comparing machines such as optical profile protector or by testing manually using gear tooth vernier caliper. Its special features which differentiate it from other machines or testers are as follows. First, it applies the accuracy up to 1 micron. It is light in weight and hence it is portable. Weight of machine is 30 kg approx. Requires very low maintenance. Its setting time is less. It requires very low flow space area. Its manufacturing cost is also very low. No separate arrangement of drawing sketch is required. It requires low power for its operations. Hence, it can be excited using DC, power and DC motors, and many more. Now, my friend Dishant will tell you something about the terminology of gear which are measured in Parkinson gear tester.
Now, the topic is terminology of gear which are measured in Parkinson gear testing. What are the things we could measure in a gear with the help of Parkinson gear tester? First is concentricity of the teeth. Whether the teeth is concentric with the gear or not. If it is, then there would be no error. If it is not, then what would be that we could see that the error is there in the gear. So if there is some type of error in the concentricity of the teeth, there would be definitely a deviation in this dial indicator which can be easily seen in the dial indicator. Also it is written using a gear testing fixture with a spring loaded slide and dial indicator. in which spring exerts a constant pressure on the mating teeth, and the movement of the dial indicator gives the measure of the eccentricity of the teeth. So it is very clear from this statement we could know if there is problem or not. Second point, alignment of the tooth. It is very important that if there is alignment of the tooth or not. Otherwise there could be problem of backlash or any type of problem like the mashing of the gear. So it could be known if we use the Parkinson gear tester. So during the measurement or during the testing, if there is some type of noise created during the testing, we can know if the alignment of the tooth is proper or not, and we can also know which tooth is not aligned with the gear. Third point, double flank testing. As the name suggests itself, there would be some type of testing related to the flank portion which is below the face portion in the gear tooth. Double flank gear testing is considered a composite testing approach to gear measurement. It measures the composite of index, helix or lead, profile, and runout errors in the gear. So now what is composite testing? Composite testing of gear consists in measuring the variation in center distance when a gear is rolled during the testing. Now the characteristics to the test. Total composite error FI. It comprises of tooth-to-tooth error and runout error. Now, second point, tooth-to-tooth error FI. Tooth-to-tooth error FI is measured error between adjacent teeth of the part gear using a master gear. It is due to the nicks present in the teeth. The nicks are the problem which are created by the workers during the handling of the gear. After that, composite runout error FR. Runout error is measured by indicating the position of a pin or ball inserted in each tooth space around the gear and taking the largest difference. In simple language, the figure is shown. It is having a graph of runout error, the difference between the highest point and the lowest point is the runout. Simple, like it. Mean center deviation. So if there is deviation from the center, it is mean center deviation. Easy. After that, nicks and burrs. Already discussed what is nicks, and the burrs are the extra metal in the gears which is there between the two teeth, which is not removed during the finishing or the grinding process. Fourth point, single flank testing. With single flank testing, mating gears roll together at the proper centers, distance with backlash, and with only one flank in contact. The main difference between single flank testing and double flank testing is that here in single flank testing there is backlash, and in double flank testing there is no backlash. So here testing gears in this manner more closely simulates operation of the gear in their application than any other means of evaluations. So this was the main point of single flank testing, in which the gears which is to be tested and the master gear easily move. After that, the characteristics to be tested. Here first is Fi, the total error. Second is long wave component. After that, soft wave component. Then maximum value of tooth to tooth error and average value of tooth to tooth error. Here there is a figure shown in which long wave component and short wave components are clearly shown. The red line having the short waves and the purple line is having the long waves. After that, the maximum value of 222 error and average value of 222 error. It is similar as we discussed in double flank testing. Also, there is a good point here. Apart from analyzing the working variation, it can also acquire and calculate values such as angular acceleration of gear and pinion, structure-borne noise of bearing, or the emitted airborne sounds. Now, what are the applications and measurable quantities in our Parkinson gear tester? Here we could detect error in pitch, detect error in concentricity of pitch line, detect the total composite error with the help of double flank testing. It is also very important. It is very suitable in mass production of gears. Also to determine the variation in gear manufacturing machines and take corrective measures for the same. It is also used to check as well as measure the error in tooth form. So these are some applications of the Parkinson gear tester. Now, what are the disadvantages? First, generally 80 mm max diameter of gear can be measured as per setup. So, if we, as we already discussed in our working, and you also have been seeing the pictures of the Parkinson gear tester, there are two gears to be kept inside it, as well as there should be a movable carriage. So 80 mm is maximum what we could get in this. After that, there is low friction in movement of floating carriage, and a high sensitivity of sensing unit is important, which is not there. The accuracy is the order of plus or minus 0.25. Rolling test does not reveal all errors since the device is sensitive to cumulative position errors. Errors are not clearly identified for type, profile, pitch, helix, tooth thickness, and etc. Measurements are directly dependent on master gear. So if master gear is having any type of error, possibly there could be error in testing gear. So this is a video related to our Parkinson gear tester. So here you could see there is a dial which is continuously having deflection in it, and the gear which is connected to the dial, it is the testing gear, and the testing gear is connected with the help of spring to our master gear, and the testing gear, and the below the testing gear it is a carriage which could move, and the slider could be seen beside it. And now next, these are the references from which we have taken our whole content. Thank you. Myself Dishang Mehta and Dev Seti, who has performed this whole presentation.